So, okay, so trigonometric functions. So basically, we're talking about the universal functions. Universal functions are because they are vectorized operations and they're extremely fast, compared to these loops, which are extremely slow. Loops are really slow. Right? So we need to always go for vectorized operations. Okay? So let's do these trigonometric operations using ufuncs, basically ufunc. So let's do this. On. So okay, so I need to import numpy. Right? Import numpy as, and then we need to do let's do this. So we have a linear space. I think my list is what is linear space? So I'll just copy this. Rather than typing out. Okay. So it's so theta equal to np dot linear space 0 to pi 3. And then 0 देखि pi सम्म 3 वटा भनेपछि 0 pi over 2 अनि pi. 0 भनेपछि यो 3 वटा गर्दाखेरि इक्विडिस्टेन्ट हुनु पर्यो हैन गर्दाखेरि 0 हुन्छ pi over 2 हुन्छ अनि pi हुन्छ. So which is this? So 0, this is pi over 2 and this is pi. Pi को value 3.1459. This is pi whatever. And then, okay, so once we have that, now let's calculate some sine cos tan. So let's see. Let's say np dot sine, right? np dot sine, and then let's do theta. Right? You'll see here. Okay, so this thing np dot cos, right? Theta. Right? Likewise, we can do tan and other trigonometric functions, tangent. Okay, so it's my key. Let's quickly take a look. Okay. So theta sin. So our theta is this. So हामीले के गर्यो यो लिन स्पेस गर्यो नि यो लिन स्पेस थीटा थीटा भनेपछि के भयो भने तपाईको it goes from 0 to कतिसम्म pi सम्म गएको छ pi and then हामीले 3 वटा लिएको छौं नि त हैन थीटा 3 वटा भने we need to have 3 points including these these boundary points हैन गर्दाखेरि pi over 2 हुन्छ है अब यसको तपाईको साइन गर्नु भयो भने तपाईको साइन कर्भ कस्तो हुन्छ है साइन कर्भ कस्तो हुन्छ भन्दाखेरि यसको हाफ साइकल पाइमा आउँछ है if you remember है so let's see like यस्तो हुन्छ हैन साइन चाहिँ यस्तो हुन्छ ओके किनभने साइन चाहिँ यस्तो हुन्छ नि त so full cycle यो भयो starts at 0 अनि यो यसको साइकल चाहिँ 2 पाइ हुन्छ है यसको 2 पाइ हुन्छ अनि यहाँनेर है यहाँनेर पाइ हुन्छ है अनि we just taking this window here right just taking this window right here your window okay so does it make sense okay so your sine curve हामी पाइ सम्म मात्र लिएको छौं त है पाइ सम्म है okay so हेर्नुस् त अब यसमा यो चाहिँ साइन कर्भ यो ब्लू कर्भ छ नि साइन कर्भ सो यसको 0 मा भ्यालु कति छ हेर्नुस् त साइन को 0 कति छ 0 नै छ हैन so as you can see here 0 मा चाहिँ 0 छ हो ओके pi over 2 मा कति छ यो त 1 हुन्छ of course 1 हो है यो 1 हुन्छ भनेपछि pi over 2 मा कति भयो 1 हैन this is pi over 2 मा 1 छ है अनि अब pi मा गएर के भन्छ pi मा कति छ pi को भ्यालु कति छ pi मा y को भ्यालु y भनेको sin pi मा 0 छ pi मा y 0 छैन x equal pi हुँदाखेरि y equal to कति छ
0
0 of course हैन 0 छ नि त हेर्नुस् यहाँ 0 छ so here's the is this 0 or not extremely close to 0 so 1.22 times 10 to the power minus 16 and you see effectively it's 0 right okay so does it make sense okay so this thing here let's try now right you चाहिँ त sin को भयो likewise let's do cos को है त okay cos को curve कस्तो हुन्छ कसैले याद छ cos को
1 देखि स्टार्ट हुन्छ
okay 0 मा के हुन्छ cos 0 is के हुन्छ
-1 बाट स्टार्ट हुन्छ
cos 1
त्यस्तो हुन्छ हैन let me show you
-1 बाट
-1 कि 1
-1 बाट स्टार्ट
1
pi भयो see pi भयो हैन and we see something like this हैन okay so this is one है okay यस्तो हुन्छ so हामीले we are taking this window right here हामीले कुन विन्डो लिइरा छौं probably we can do this one है त this one हामीले विन्डो कुन चाहिँ लिइरा छौं only this part यहाँदेखि पाइ सम्म मात्र लिएको छौं है यो विन्डो लिइरा छौं यति पार्ट लिइरा छौं है भनेपछि यसको कस्तो हुने भन्दाखेरि something like one चाहिँ यहाँ अलिकति यहाँ ठाउँ त्यसले गर्दाखेरि जस्तै अब 0 मा हैन pi over 2 okay so pi over 2 मा 0 हुन्छ हैन so isn't that right pi 0 भयो pi over 2 मा 0 हुन्छ you see something like this and then यस्तो हुन्छ है so यसमा यतातिर 1 यहाँ चाहिँ तल minus है त ओके ल यो अनुसार लगाउनुस् त अब cos को 0 मा कति भयो
1
okay very good है cos 0 मा 1 छ है cos pi over 2
0
which is effectively 10 to the minus 17 is effectively 0 okay अनि pi मा के हुन्छ
-1
very good yes -1 take this one just minus right and so on okay so tan को त तपाईलाई थाहा छ sin over cos all right so okay anyway so let's see I mean the point is that you can do easily you can even use trigonometric operations you can use trigonometric operations with trigonometric operations okay? Which is very convenient so likewise you can do exponential logarithms okay? So very simply exponentials or e to the power and e could be to the power so e to the power we can have this you function e to the power x simply also he is not nearly is I'm still thinking in terms of math so exp and the x so this is the function okay so right here right okay exp right e to the power 0 is 1 of course e to the power 1 is 2.71 you can equal value 2.718 right and e to the power 2 and e to the power 3 and so on even natural number natural n plus 1 over n to the power 1 limit as n tends to infinity, right? So anyway, so this go value is 2.7. Okay. Anyway, so the value this thing we can do all these powers through. I want to say 3 to the power each of these, right? 3 to the power 0, 3 to the power 1, 3 to the power 2, this one, 3 simply 3 to the power x. That's it. Oops. Oh no, it's integer power. So integer power. Power, and this is you can do 3 to the power x. See, yeah. 3 to the power 0 is 1. 3 to the power 1 is 3. X is 3 to the power 0 is 1. 3 to the power 3. Okay, 3 to the power 1 to the power 3. And 1 to the power 3 still okay. That's sorry. 3 to the power 1, 3 to the power 3 to the power
3 to
1,
the power 1 wala, sir.
power 2, and 3 to the power 3, and 3 to the power 4, right? And so on. Yeah. Thank you. Right? Anyway. So so this city, I mean the point is how easy it is. I know how easy it is, right? Okay, so logarithms when this thing. So you can do all these logarithms. Log is easy. So I don't have to do each of these. It's in the notes. Right? And we did log. And this is the log x and x 1, 2, 3, 4, 7. Right? See? And then log 1 it's 0. Log 2 log you log base 10 you log base 2 you sorry you log base natural number ln. You see ln, right? Log simply you like your ln also ln natural log, right? Natural log you say log base 2 log base 10, right? And likewise, right? Okay, so advanced Fourier features, aggregates. For binary functions, there are some aggregates that can be computed directly from the object. Right? Reduce and accumulate. Right? Reduce repeatedly applies a given operation to the elements of array until only a single result remains. Right? So you'll see there's the reduce, accumulate, very very convenient functions. Right? So let's try them out. R is equal to range and it's the same here. Okay, we can do np dot add dot reduce, right? Reduce यो गऱ्यो भने के हुन्छ भन्दा यसको सबैको के आउँछ भन्दाखेरि सम आउँछ नि 0 + 1 + 2 + 3 and सबै जोड्दा कति हुन्छ दिने 45, right? So if you add them up you should get 45, right? So reduce ले के गर्छ भन्दाखेरि यसले चाहिँ यो एड गर्दै जायो अनि त्यसलाई चाहिँ त्यो हैन त्यो यसको एक्युमुलेटमा तपाईलाई थाहा हुन्छ यसैमा I can do accumulate reduce if I do accumulate गरे भने चाहिँ तपाईको individual जुन running sum आउँछ नि you'll get the running sum, right? See 0 हैन सुरुमा 0 मात्रै छ 0 + 1 is 1 अनि 1 + 2 is 3 हैन 3 + 2 3 + 3 is 6 हैन अनि 6 मा 4 जोड्यो 10 भयो 10 मा 5 जोड्यो 15 भयो and so on, right? So it's a running sum. This is just a running sum, right? The running sum. Oh. Right? So I hope you guys understand this. You बुझ्नु भयो कि बुझ्नु भएन भने I will draw, I mean skip यो बुझ्नु भयो running sum बुझ्नु भयो
हजुर सर
This we can do यसैमा हजुर बुझिराख्नु भएको छ. All right, so you can also do like, for example, multiply, right? Multiply with the 0 on this. So multiply, it doesn't make sense to multiply. Let's do it. 0 also. It's a 0. Surumai 0, sir. So it doesn't make sense to do that. Okay. So okay, multiply. Likewise, you can do other operations as well. And so you get them in multiply. say this 0 देखि नगरिकन 1 देखि 1 to 10 1 देखि 10 so now we can do multiply as well, right? So this is our hair, right? And this is np dot multiply np dot multiply and you dot is the reduce, right? That reduce, right? So quick multiplication that is okay, right? 1 times 2 times 3 times 4 times 5 and so on, okay? And so it's going to be 36,000. It's and we can do same here. We can accumulate. We discuss the accumulate. And you can see that. Okay, then you get the running multiplication, right? 1 times 2, right? Okay, and then the next one is 3, 6. And then 6 times 4 is 24. 4 times 5 is this, right? And so on. Okay. So you play, right? Okay, so there's something called outer product, right? Outer product. Is for this, I need to explain to you a couple of things, right? Inner product or outer product, right? So that's the inner product, outer product. So let me show you. Right. So, okay. So inner product or outer product. Okay, let's see. But dot product for net has some.
Yes, sir.
Dot product के result के मध्य
Scalar.
That's right. That's right. Dot product. इसको result चाहिँ के आउँछ scalar आउँछ. Just a number, हैन? Okay, scalar आउँछ. त्यस्तै गरी अर्को के छ outer product. Outer product अनि cross product. Cross product. Cross product ले के दिन्छ भन्दाखेरि it will give you a matrix, of course, हैन? Cross product ले के दिन्छ matrix दिन्छ. Isn't that right? Okay. So the dot product लाई हामी के भन्छौँ भने we also call that inner product, हैन? Between dot product के हो inner product. Okay? inner है अनि cross product चाहिँ के हो outer. Inner outer, right? So let's try a few things. Say dot product. So I have, for example, U and V, right? U to V. There are two vectors, U vector and V vector, right? U to V data vectors, right? So it's normally vectors. Dot product. So let's see. Let's say Franco. Eurovisa. These both are. This is right, column vectors. Called Eurovi, the way column vectors. So when you see, let's say simple, right? So 3 by 1. 3 by 1. So column vectors Eurovi. So isma if you do इसको shape के हुन्छ भन्नुस् त U को shape कति छ दुवैको 3 by 1 हैन okay both are 3 by 1 right 3 by 1 matrix यसको shape चाहिँ 3 by 1 हुन्छ right okay so far so good right so if I do this okay let's see हैन U V transpose के हुन्छ U V transpose U matrix multiplication with V transpose. Okay. Okay. Sorry, cute. Okay, so when we say V transpose, that अब इसको shape के form मा आउँछ
3 by 1 or 1 by 3.
Very good. Yeah. 3 by 1 यो त चेन्ज भएको छ यो जे छ त्यही नै छ तर v ट्रान्सपोज अब के भयो
1/3
भनेपछि यसको रिजल्टेन्ट के भयो रिजल्ट कतिमा आउँछ रिजल्टेन्ट शेप के हुन्छ रिजल्टको शेप
आउटर गर्यो भने चाहिँ 3/3 हुन्छ
भने यो केसमा है यो केसमा चाहिँ के छ भन्दाखेरि यो दुईटा they fuse together हैन and then we get a 3/3 यो जुन यो जहिले पनि मल्टिप्लाई गर्दा यसरी म्याट्रिक्स मल्टिप्लिकेसन पनि हैन ओके सो 3/3 पाउँछ है भनेपछि यो के होला UV ट्रान्सपोज गर्यो भने के आयो इज इट इनर अर आउटर डट के क्रस
आउटर
यो चाहिँ के भयो दिस इज यो चाहिँ के भयो आउटर हैन यो चाहिँ आउटर so likewise if you do this हैन U transpose V गर्यो भने के हुन्छ U transpose V गर्यो भने के हुन्छ होला U transpose गर्दाखेरि के भयो यसको शेप के भयो
1/3 3/1
very good 1/3
3
3/1 भनेपछि
3/1
yes अनि यसको रिजल्ट कतिमा आउँछ
1
1 yeah,
because
because it goes away they fuse together it goes away and then 1 by 1 right remaining 1 by 1 भयो है जहिले पनि तपाईं जसलाई यो याद छ हैन तपाईले पढिसक्नु भएको छ यो भित्रको चाहिँ मिल्नु पर्छ है नत्र मल्टिप्लिकेसन गर्न मिल्दैन यो दुईटा मिलेन भने चाहिँ मल्टिप्लिकेसन गर्न मिल्दैन यो दुईटा मिल्नै पर्छ जब अनि त्यसको रिजल्टमा चाहिँ यो दुईटा यो हराउँछ के यो फ्युज हैन यो फ्युजेस टुगेदर यो हराउँछ अनि यो बाँकी जुन बाहिरको रहन्छ त्यही नै त्यसको रिजल्टेन्ट शेप हुन्छ हैन यो 1 by 1 बेसिकली भनेको 1 नै भयो भनेपछि यसमा के भयो भन्दाखेरि अब यो चाहिँ स्केलरमा गयो यो चाहिँ स्केलरमा गयो अनि यो चाहिँ त्यसले गर्दाखेरि दिस इज व्हाट इनर प्रोडक्ट यो चाहिँ इनर प्रोडक्ट है त ओके अथवा यसलाई आउटरलाई हामी क्रस प्रोडक्ट पनि भन्छौँ अनि यसलाई चाहिँ हामी डट प्रोडक्ट भन्छौँ है इनर सो फार बुझिरहनु भएको छ अब हामीले यहाँ गर्न खोजेको चाहिँ के भन्दाखेरि we try to do this one outer product है outer product गरेर the UV transpose है UV transpose है so दुवै कलम भेक्टर छ भने दोस्रोलाई चाहिँ हामीले ट्रान्सपोज गर्यो भने we get a cross product okay so that's what we're trying to do है okay so let's see अब हामीसँग त्यसको लागि we can use the outer method है outer say x equal to NPA range हैन 2 to 11 so हामी त्यति ठुलो लिनु पर्दैन हामी सानो लिनु 2 to 6 है त यसमा के क्वेशन्स छ so let's NP dot A range 2 to so okay 2 to 6 2 3 4 5 it's our terms 2 3 4 5 okay so R is equal to NP dot A range yes now मैले if I do outer product on itself right यसैको outer product गरे भने के आउँछ right okay let's try this and then first let's try and then so here okay so so R is equal to impedance right okay so हामीले भनेपछि हामीले यो दुईटाको R हैन क्रस प्रोडक्ट है R र R कै क्रस प्रोडक्ट छ के R र R यो दुईटा यो केसमा के भयो भन्दाखेरि हाम्रो चाहिँ it's what horizontal right horizontal vector अथवा रो भेक्टर है यसमा चाहिँ यो दुईटै रो भेक्टर हुन्छ So row vector भएपछि हामीले के गर्नुपर्छ भने यसलाई चाहिँ अब हामीले पहिला म्यानुअली पनि गर्छौं है you can do manually then we can do using the method which is automatic right so हाम्रो array चाहिँ कस्तो हुन्छ भने 2 3 4 5 and यता पनि 2 यस्तो छ so अब यसलाई चाहिँ अब के गर्नु पर्यो भन्दाखेरि let's see we want to do the outer product okay, outer product see यसको shape कति छ भन्नुस् त यो these are now they have gone into vector form है vector form मा गएको छ so भनेपछि कति भयो 1 by
1/4
यो पनि 1 by 4 हैन अब हामीलाई outer product गर्नलाई कुनलाई ट्रान्सपोज गर्दा ठिक हुन्छ पहिलोलाई कि दोस्रोलाई दोस्रोलाई भन दोस्रोलाई गर्यो भने फेरि के हुन्छ 4 by 1 हुन्छ 1 by 1 हुन्छ नि त रिजल्टेन्ट
स्केलर आउँछ दोस्रोलाई गर्दा
भनेपछि के लागि गर्यो भने 4 by 1 हुन्छ या द्याट्स राइट हैन भनेपछि यसलाई ए लाई ट्रान्सपोज गर्नु न माथि यसलाई ए यसलाई बी भन्नु सो ए लाई ट्रान्सपोज गर्दियौ हैन अनि बी लाई चाहिँ जस्तो जस्तै राख्नु है त्यो गर्यो भने चाहिँ मेट्छ किन भन्दा ए ट्रान्सपोज गर्नु भने के हुन्छ 4 by 1 हुन्छ यता 1 by 4 हुन्छ हैन यो मिलाएर जान्छ and then we'll have 4 by 4 ठीक छ है so let's try this है हामी पहिला म्यानुअली नै गरौँ है यसरी नै गरौँ है यसलाई म्यानुअली गरौँ and then त्यसपछि you'll see how it's done automatically in one line of code very simple हामी यो चाहिँ हामी by hand है त so हामी के गरौँ भन्दाखेरि we need to first convert this to like array मा convert गर्नु or we can do the other way around है हामीले चाहिँ के गर्नु यसलाई चाहिँ array लाई हामी केमा लैजाउँ vector form मै लैजाउँ है column vector मा लैजाउँ जसले 2 3 4 5 हुन्छ गर्दाखेरि हामीले दोस्रोलाई ट्रान्सपोज गरे पनि भयो है यस्तो नगरिकन हैन अब हाम्रो ए चाहिँ यो फर्ममा छ हैन बी पनि यही फर्ममा छ हैन यो चाहिँ अर्को अप्सन है probably this is easier है है so यो एउटा अप्सन भयो यताको है त्यो चाहिँ म मेट दिन्छु so rather I think we so त्यसरी पनि मिल्छ so let's choose the easier option के भन्दाखेरि यसलाई रिसेप गरेर हामीले simply we can make it a column vector a column vector गरेपछि जुन अघि हामीले एक्सप्लेन गरियो नि just like that है so हामी के भन्छ यसलाई चाहिँ AB ट्रान्सपोज गरे भयो किन भन्दाखेरि यो चाहिँ के भयो भन्दाखेरि 4 by 1 छ हैन हो यो पनि 4 by 1 छ भनेपछि मैले 4 sorry by 1 भनेपछि मैले कुनलाई ट्रान्सपोज गर्नु पर्यो भन्नुस् त A B ट्रान्सपोज AB ट्रान्सपोज गर्यो भने यसले चाहिँ हामीले के दिन्छ फेरि आउटर प्रोडक्ट है मेक सेन्स किनभने AB B ट्रान्सपोज गरेपछि 1 by 4 हुन्छ ट्रान्सपोज गर्दाखेरि अनि यो बिच गराएपछि 4 by 4 आउँछ रिजल्टेन्ट चाहिँ 4 by 4 right makes sense okay let's quickly do that right okay so and then let's see अब यसलाई कसरी लैजाने यसलाई भेक्टर फर्ममा कसरी लैजाने भेक हैन भेक 1 is equal to के हुन्छ here see take all the rows अनि np dot your axis है अस्ति गरे पनि हामीले remember then this is भेक 1 है remember okay so यसरी आयो अब यो गरेपछि अब हामीले के गर्नु मिल्छ भन्दाखेरि np dot matrix multiplication है matmul भन्छ हैन matmul भनेको matrix multiplication यो रेगुलर मल्टिप्लिकेसन होइन है रेगुलर मल्टिप्लिकेसन फेरि तपाईको एलिमेन्ट वाइज हुन्छ है यो चाहिँ matrix multiplication अनि भनेपछि हामीले के गर्नु पर्यो भेक 1 हैन भेक 1 कमा अनि के गर्नु भेक 1 नि ट्रान्सपोज हो ओके भेक 1 डट t गर्यो भने ट्रान्सपोज हुन्छ है so let's see so this is the outer product है यो चाहिँ भेक 1 को आफैसँगको outer product चाहिँ यो हो है भनेपछि कति भएको 4 by 4 को आयो हैन 4 by 4 है so okay so तपाईहरुलाई यो matrix multiplication थाहा छ नि हैन है सबैले थाहा होला so I won't go into that right? so यसरी matrix multiplication हुन्छ है okay so अब यही कुरा हामीले अब यत्रो गरियो नि यस्तै यहाँ यसलाई यसमा कन्भर्ट गरेर अनि त्यसपछि म्याथ मल गरियो यो चाहिँ एउटै स्टेप हुन्छ कि right? It's your step on say np dot exactly np dot outer np dot multiply np dot multiply dot outer right? Dot outer आणि add error let's see I get the exact same result. So when we say I'm doing यसरी by hand manually गर्यो नि step by step अब यसले चाहिँ यो सबै उले टेक केयर गर्छ everything उले चाहिँ outer भनेपछि उले हैन it takes care of right simply I'm दुईवटा एरे दिनु outer products right? So any questions on this? Excellent. All right, so that's how you get the. You can also simply you can be very simple, very kind of easy. All right, so let's see. Another one is aggregations. I'm still not 5 minutes. Aggregations mean, max, and everything in between. Right? Summing the values in an array. Okay, so let's see. We have this. Okay. So aggregations. So basically we do random to random 50. So that's random number series. Did I explain really uniform distribution or uniform normal distribution? Okay, anyway, so it's coming from the what uniform distribution, right? It's coming from 0 to 1. It's coming from uniform distribution, right? So and I can just very simply do np dot sum. So something you just even some number right? It's called addition, right? So because sum so we have different set. So because sum, right? This is what 22.3906, right? Okay, so okay, we can do you can use rather you can use you're not going to use a numpy sum, and there's also sum. I'm using core Python. Core Python is built-in core Python sum. That also works, and that also works. Look at the slight difference, but so slight difference. Which one is fast? Let's put this. This time time it. We don't time it. Time it as well. Right. So it's on time it. It's a time it. I'm very huge array. Right. Let's make a huge array. Like say use means. So for example, it's 1 million. Right. This 1, 2, 3, 4, 5, 6. Right? 1 million. Right. 1 million what? Number circle, right? Make this array, right? And this is the percent and this and we dot sum, rather by the sum neighbor. Sum and then add. Sum add. 301 milliseconds. Okay. So how about this? Is np dot sum. Okay. So 301 millisecond, 1.82 milliseconds. Which one is faster?
Right?
Of course, NPR. You see, this is faster. Let's say 1 millisecond equals 1.8. Right? Almost 150 times faster. Okay. So okay, or 20 times faster. Okay. So this is a micro or milli macro. So let's try again. I'll say fast there. Okay. Okay. So, let's try it. We've got 61 milliseconds. Let's okay, so as you can see, okay, minimum and max. Okay, Python has built-in min and max. Okay, okay, it's the same thing, right? Same thing. Like bigger area. I don't have to show you. Still, if this thing 1.83 to 161. Okay, so okay. Okay. So our question of mean and max. So this thing is np.min, np.max. हाम्रो होइन built-in पनि छ. Built-in जस्तै built-in man means 4 pi. 4 pi means यसको numpy को means, and you can compare these two. Yes, it's the comparison. Right? So I'll leave it out. Okay. All right. So let's see about multi-dimensional aggregates. Aggregates are one. We saw rather 8-minute mathematics. So I'll stop this session. Please come.